And hello and welcome back. Right now, I'm looking is at the GraphQL section here, making a quick recap of the entire GraphQL section here. That since GraphQL is a query language, a new way of building front end and back end, and it all starts by describing is the data as a schema. And if you want to ask for the data, you use queries for that. So the beauty of this is that with GraphQL, we can see how all of the different pieces of data relate each other in our server. So much like selecting a property in an object, uh, with GraphQL, one of the great thing of that is since the GraphQL query really match closely what the resulting object, or what is the resulting object, we can predict what our query will result, including is the property, regardless how the data is stored. So whether you use as a database like document based or relational graph, key value, uh, or white column, the question is why do we choose to go with GraphQL? Because this is something that was developed by Facebook and is a new way of building and interact with APIs. It solved couple issues. Something called the underfetching and overfetching, where the underfetching means we lose additional or we lose time making additional requests for querying multiple collections that increase the load page time. So that's one of the issues, the underfetching. And the other is overfetching. So since our server sends additionally unnecessary data to the client, we need to filter out to display the relevant data for the user. So with GraphQL, by just having one single entry point, it solves the underfetching problem. So you only need to hit that GraphQL endpoint, uh, and you get only the data that you ask for. So solving is the overfetching issues. So with RESTful architectures and GraphQL architecture, that's one of the trade-off where these companies such as Facebook were facing, and the whole idea is to reduce the load time and the number of requests you make to a server for asking for querying multiple collection of data to compose them in the front end. So from the GraphQL specification here, so they say that they are unapologetically uh, front end based. We look at the overview here, specifically here, product centric. So GraphQL is unapologetically driven by the requirement of Vue and the front end engineering. That's right there. So it is for the client side specifically, or for developer for front end developers, right? So GraphQL start with their way of thinking and requirements and builds a language and runtime necessary to enable that. So because this is one of these issues that GraphQL solves, the underfetching and the overfetching, and also, which is one of the advantage that provides type and schemas, speed of making the development process faster. The trade-off is that since this is a new way of building APIs, how do we interact with how engineers now interact with them? This flexibility adds complexity. That's one thing. It also, since with RESTful architecture we already have proven methods for catching. So catching is something that is an advanced topic. It's not that out of the box, much like the RESTful architecture. And it's not RESTful, meaning that because RESTful is an architectural design that has been over several years, even decades, uh, engineers are very familiar with that. But now they need to learn is this new way of doing things. So okay, even though, right, after I saw the specification, who made that, and the frameworks that allow you to use GraphQL, for example, Relay, that we have that here. So, for example, Relay, okay, which was built by Facebook to work with React framework, and more high-end products like Polo, where allow you to build front-end and back-end GraphQL applications. So first we need to understand is, and thanks to Zero to Mastery in structures, that they show us is how to create our GraphQL server from scratch, because we need to understand is the know-how. So we use this Express for that, and an Express middleware. So the whole idea here is the beginning. So to get familiar yourself with the concepts and the functions that are necessary by default, and you might find in any, you will find, not might find, you will find in any application or any GraphQL service. Okay, so for example, like the build schema, where you define is a type system. Like when you go here to the GraphQL specification, here the type system. Okay, so the graph or the type system describe the capability of the GraphQL server, and it is used to determine if a request operation is valid, define or guarantee the type of the result in the response, and describe the input value of variables to determine if a value provided request time is valid. So yes, first I look at the GraphQL server, the most simple example of a GraphQL server using the type to define a query. All GraphQL server have that, where you lay out inside of that is the different types that your GraphQL server support, and the root value. All right. So once we navigate to that, once we run this code using is npm .star. If you use this a package.json, if you use this the npm init to generate a package, a default package JSON, and define is the index file here. So the only thing that you have to do is npm run or npm start. So it will run. So this is a shorthand for run and a script that start with star. So yeah, so here we use this, and again, this express middleware and the build schema that allow you to define the type system. And then we use tools like Postman's and Insomnia to query the data. Uh, so after all, a GraphQL server is no more than another HTTP server where to query data you use the HTTP post verb and pass as in the body as a raw JSON is the type of data that you want, right? So for example, it all starts with query and the type of data that you ask for. So this is to understand is how GraphQL works and what is going behind the scenes. Then once I look at the large-scale GraphQL server, for example, designing an e-commerce schema, deep nested objects are very common in e-commerce application or any application with some technical depth. So makes GraphQL a perfect case for using. And it is actually amazing how easy it is to query really complex data for exactly the data that we need. So our API now is organized in types and fields rather than endpoints. So which making query multiple endpoints to combine data unnecessary, like in a RESTful API. So because of that, okay, and again, now this is a more or this is a more realistic project, okay. And what I'm doing here is just a huge overview of what I have learned so far with the GraphQL section from Zero to Mastery. So then I look at tools that allow us to make our GraphQL server more scalable, GraphQL tools. So by asking questions like, how do we split, okay, different types into multiple files? How can we organize our server by features? And how can we organize our logic when we ask for complex data and fetch that to the front end, right? This kind of question that I set here. Okay, so organize. So how can we organize our server? So when we need to add more complex logic to fetch our data, that is part of the redundancy. Something that I'm going to explain later. So in any case, so GraphQL greatly help us here. It's an open source set of utility that simplified how we create GraphQL server. And underneath the hood, Apollo used that. So since Apollo is a service company of GraphQL, it's not a good idea to fully commit to their service. Again, it's up to you based on the business decision or the decision maker in your company and what if they are aligned to Apollo, but just for info purpose. And then because I want to use this GraphQL tools and to see how can we create this scalable GraphQL server by organizing or by modularizing our schemas using is the GraphQL tool called schema that allow us to pass an array of types to the build schema, but in this case we make use of makes executable schema for that. So when I back here, like this makes executable schema. Okay, this actually comes from the GraphQL tool schema, and since Under the Hood relies on GraphQL, it is highly compatible with GraphQL HTTP server, or in this case is the GraphQL middleware express and the GraphQL package. So yes, so the way to organize or to modularize our applications or GraphQL applications from schemas is to, well, split your GraphQL types into files that end with GraphQL. So for example, here we have is the order. Okay, again, we define here is the type of this. And again, remember, this is the entry point for all of your GraphQL servers. And here what we can define is all the relevant type for this uh, uh, type, for all the relevant types for this document, this collection. They call this document here, the specification. They call the schema here as a description, schema extensions here. Query, the query root operation type must be provided and must be an object type, part of this. Mutation subscriptions and query. Schema directive, root operation type definition, and schema description here. So translate. Okay, but this is translate string to a given different language. Description and string. Documentation is a first-class feature of GraphQL type system to ensure that the documentation of a GraphQL server remains consistent with its capability. So they call schemas here, types. Okay. So they call the types here, these types, all right? So they call this type as it can be in a scalar, object, interface, union, types, enums, and inputs. And since we are here looking at the type definition, which is a type system definition or type system document, okay, they call also this type as document. Document if you have nested, if you have a list of type system definition, where it can be a schema definition, type definition, or directive definition. Okay, it is important to also look at the documentation here to kind of guide you where it's all about and the terminology as well. Okay, so type definition here, the schema definition, okay, the schema, the type definition here, where are the types, and the directive, the directive here. Okay, query mutation subscription field fragment. Okay, the directive. Okay, and the built-in directive here. Okay. Okay, so in other words, to make it simple, so here this is the way of how we organize schema or make our GraphQL server much more modularized with schemas by splitting it the type in different files, using is the or creating files with that with an extension or that end with GraphQL, and then as I move on here, and then now I look at how can we use, for example, uh, from the GraphQL tools load sync to actually load all of those files in sync, meaning that you have to wait, or the Node.js server have to wait for all those files to be loaded before do anything. So this is a blocking operation. So load file sync, if we look for that in the GraphQL tool, I'm assuming that GraphQL tool nodes. Oh, you got. What about load file? API documentation here. The guild.dev. Okay, they already have that. No functions, low files. In a promise base, asynchronously load files using the provide block pattern. That's right. In file sync, synchronously load using the provide block pattern. Exactly. So if you use this, so your server, this is a blocking operation. Okay. So load files like this is a blocking operation. Why? Because the server at the beginning, it needs to wait for all of those files following this blob pattern, or this regular expression, this blob pattern, to load all of those files before do anything else. Okay. So this is only for the schema. Okay. As I look and as I move on with the next section from the GraphQL model, resolvers is another component in any GraphQL schema or in any GraphQL server. So we have schema and resolvers. So what are resolvers? The answer lies is in how GraphQL query works. So anytime a query or anytime, so GraphQL always check if a GraphQL query is valid. If it is, it will then execute that query to resolve and if to determine the value of the property. There's a function called resolver that does that. So in other words, resolvers resolvers verify and so resolvers determine the value of a property when a valid query is made in the GraphQL server, right? So when you define, for example, here, I think we already have that running, yes. So if I look here, the local host, the GraphQL, okay. So when you define property here, that's right. So yeah, so when you define properties in a GraphQL query, the server, if it is a valid query, the server call the proper resolver for each one of those fields, and then wrap it up and send back to the front. And it's important to understand this, and also how you can tell to others. It's like, hey, this actually works like that. Blah, 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 blah. Why? Because it not only makes you more professional, but also understand the know-how and ultimately, well, provide the value that the client is looking for. So, okay, since we were using is the root value at that moment, and we are loading is the data using is a JavaScript model or a common GX model to be precise. So the root value is so determining what data comes from our API, right? So instead of using is the root value or from our hard-coded data, which is not realistic, so we need a function called resolvers that it comes with the makes executable function. And here is where you define is a resolver, right? So right now we have something called resolver array. And the reason is because if you want to modularize your GraphQL server for the resolvers, now the way to do that is first you create a file that ends with .resolver.js, and inside of this, for example, here, and inside of it, you're gonna export that model with this type of a structure. You export that the query and the proper or the proper property, or you export this query with the property here that you're going to call or that you want to invoke when a particular type is being used or is being called. Okay, so with our orders here, because this is just for demo purpose, we just want us to see what is doing behind the scenes this resolver and the anatomy of the resolver function, where the first argument is the pattern, where you receive is the root value. The second argument is the R that something that I define here. So it's being used when we have parameterized queries. So for example, filter out data with under some condition. So something that we're going to see later and that we apply that. So R is what we receive is the parameter. Okay. So R is being used when we have parameterized queries. Cool. That's when we can use R, when we have parameterized queries. So for example, filter out data with under some condition. Or filter out data with some condition. Okay, with some condition. Then we have something called the what is the next? The context, which is used to share data across different resolvers. So, for example, if we want to pass authentication data about which user logging to every one of the resolvers. So passing authentication data to each one of those different resolvers, that might be one case of using the context. And the other is the info, right? Provide you data about the current state of the resolver or the operation. Okay, most of the time we barely use all of that. Those are from advanced scenarios. In modularizing this, they're talking about modularizing a GraphQL server. So orders.resolver.js here. And if we want to include that in our server, again, we use now the log file sync from the GraphQL tools. And in this case, we're using the path for that, which is a model from Node.js. where you call join and pass is the dir name, the current folder structure, the current uh, the current location from this file, following a blob path. Okay. Uh, so in large scale project, blah, 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 this is something also important, because in large scale project you have the data layer, for example product model, and this function will make whatever API call we need. So in any large scale applications we have a data layer. For example, the orders of model, this is the data layer. Okay. uh, where you invoke is your API code. So right now, for the sake of the example, here we're getting is our data from in memory, an array from that. So we define here is a function get all orders and return that collection. And since we are, again, this is the data layer that will make not only it will make our GraphQL servers scalable, because the only logic that we are handling here in this file is this asynchronous API call. Whether you're using this or regardless the database you're using. So by using is the model.export, okay, this CommonJS function. So we pass that as reference. It's important here. So we're passing here as reference, and when we want to invoke them, which is in our resolver, in our orders resolver. Let me close all of this to avoid any confusion for that. And in our resolver orders resolvers, so we just only return. So we call is that particular function from the data layer. Okay, but there are several distinctions here when you are creating, for example, server or scalable servers, right? You have the uh, incoming request layer, or the request and response layer, and the data layer for that. At least this is the two main layers, most significant in any server, in any Node.js application, right? Or I'll argue that in any server. But for Node.js applications, you have is the routing layer, the request and response, and the data layer to perform async operations. And usually a database or any other servers uh, where you ask for data or send data. Okay, cool. So here, once we fetch or once we query for orders, for example here, so once we query for orders, okay, we can do something like this. Instead of calling this, we're gonna call is no, no, oh come on, oh come on, the product. This one is to fetch this entire list and only get the description data from that. So when I hit run, and that's right. Okay, so that's it. That's it. So we're getting is this really, this nested complex data, and only the relevant data that we want to show to our users. That's great. That's great. And here, well, we print it out in the console, getting the order. Cool. Also, we can use mimicking is the behavior for any async operation, something that we did like here, okay? Because if you look at this, we're calling it the product, but here we are creating is an async operation using the promise.resolve and call that function from the respective data layer product model, and return is products. Okay, so a more interesting and realistic use case of resolvers are with parameterized data, which is where we are here. So here we are going to see a more practical use case for resolver function. So when we pass some arguments and use those arguments to filter out data that come back in our query. So what if we want to get a simple product by its ID, or filter out products plural? Okay. So what if we want to get a single product by ID, or a filter out products with by some price range or any criteria? This is very super common use case. And the GraphQL approach is to use parameterized queries. Again, a more realistic and practical use case for resolver. So the GraphQL approach is use parameterized, parameterized is parameterized queries. So we're going to add a new query like that. Okay. Okay. Is that so? Parameterized queries. So we're going to add a new query. Okay. And the way we do this is by going at the proper schema. In our case, is the product, the proper schema, and here we define another query. It is funny how they call this. So they call this any type we define in our query as query. We define a query. That makes sense. They're all. That makes sense. So here we define is another query, product by price. To make our life simple and for demo purpose, so to avoid to have, so to not check if the value that we're receiving is undefined or if it is a valid. So here we just pass this require reserve word, in this case reserve character, okay, float, and we define is the return object, a list of products or a collection of products. So okay, first if we want to define if we want to define a query, if we want to define a parameter, if we want to define a parameterized query, we rely on defining that on the query object, and in the proper resolver, okay, now, which is in our case here, and in the proper resolver here, problem by price, call that function from the data layer and pass the argument. Okay, so one of the best recommendation or good approach, one of the best practice from GraphQL is if you're not going to use a parameter, use a underscore for that, right? So here, since we are defining is in the GraphQL type. So let me close now the orders because now we are on products. Okay, since we define our products a parameterized query, since since here I define a product, since I define a parameterized query in the products, so product by price, okay, and now calling a proper function from the data layer in the product model, okay, and inside of the model, remember again, since we are calling is this collection in memory like products, okay, and then we return is the product filter and the product price, mean, and the maximum, right? So the challenge comes is from the Zero to Mastery course, where they tell us is to implement like this. So what they tell us to implement is now a product by ID. To implement a product by ID. You got it? 85%. Ooh, we're getting close. We're getting close. We are getting close. Holy fudge, nigga. We are getting close. Okay, here we go. Filtering with queries and results. Modularizing large GraphQL projects like this. And yeah, I already saw this. Okay, so filtering with queries and resolvers. So I can move on to the next. Here is exercise. Query exercise. Query product by ID. Okay, so querying products by ID. Okay. Querying products by ID. Exercise here. Querying products by ID. Right. Okay. Let me add a proper format here, and since we don't know how to actually query types like that, because here we are in this is the type system and introspection, validation, and execution, executing request, executing operation, executing request, and the response format, in serialization format, application serialization, and serialized map ordering. Notations convention, context-free grammar, appendix grammar summary, selection set. Okay, selection set. This is from the language. Okay, selection set. Field fragment spread or inline. An operation select the set of information it needs and will receive exactly that information and nothing more, avoiding overfetching and underfetching data. The two issue that GraphQL solves. In these query operations, the ID, first name and last name fields form a selection set. Selection set may also contain fragment reference, or it can contain its fragment reference. It's here. Fragments. Fragments are the primary unit of composition in GraphQL. Interesting. So fragments are allowed for the reuse of common repeated selection of fields, reducing duplicated text in the document. Inline fragment can be used directly within a selection to condition upon a type condition when querying against an interface or union. For example, if it wants to fetch some common information about mutual friends as well as friends of some users, friends, mutual friends, the repeated field will be extracted into a fragment and composed by parent fragment. And the repeated field, okay, and you define it a fragment. Damn. Friend fields on user. Damn, son. Holy crap. Holy crap, nigga. Holy moly. Okay. I love it. I love it. I love it. I love it. My internal geek say, fucking what? Yes, great.
Welcome back. Believe it or not.
Nope, nope, nope. Stay, stay, stay. But in any case, here we want to do selection set operations, right? Operations like this. There are three types of operations that GraphQL models: query, a read-only fetch; mutation, a write followed by a fetch; subscription, a long-lived request that fetch data in response to source event. Interesting. Okay. The operations. The important to read the documentation. So we have in operations query, mutation, and subscription. So query shorthand. Exactly. Query shorthand. And you have a mutation here. Okay. So for example, this mutation operation might like a story and then retrieve the number of like. If a document contains only one operation, of that operation is query, which defines a variable. And exactly. So by default, GraphQL query fetch data. But it says query mutation. So for example, these mutation operations might like a story and then retrieve the number of like. Okay. This is the operation. Oh, interesting. The three type of operation that GraphQL models. Okay, but in our case, because you want to implement is only here, so source text, Unico, white label, down, lexical, and names, name convention, and document, right? So a GraphQL document describes a complete file or request string operated by a GraphQL server. The definition here can be a list. The definition either a representative of GraphQL type system. And then you gotta see operation. Okay, documents are only executable by GraphQL servers if there are executable documents. And that's one of the reasons why they use make executable schema. If they have executable document and contain at least one operation definition. A document which contains type system definition or extension must not execute. GraphQL extension service which receive a document containing this should return a descriptor, but the relevant thing is that if a document contains only one operation, that operation may be unnamed. Interesting. If that operation is a query with a variable or directive, then it might also be represented in the shorthand form. Okay. Again, this is using the language to describe that, omitting both query words as well as operation name. Otherwise, a GraphQL document contains multiple operations. Each operation must be named. So selection set, field, argument, exactly, now the arguments here. Fields are conceptually functions. Interesting. So fields are conceptually functions which return value and occasionally accept arguments which alter their behavior. These arguments often map directly to function argument within a GraphQL service implementation. In this example, we want to query a specific user request via the ID argument and the profile picture of specific size. Many arguments can exist for a given field. This is interesting. Arguments are unordered. Arguments may be provided in any syntactic order and maintain identical semantic meaning. These two operations are semantically identical. Good. Field alias name. What the hell? Field alias and name. This is you want to create a which return the result. The field at the top level of an operation can be also given alias. Suck. You suck. Or user ID. Okay. An alias, which return the result by making a query. Okay. And then you have the fragment. You can also create this fragment composition. This is very interesting. Input values. Exactly, defining all the input value here. You can define here. Boolean value, string value, null value, and null value. We're representing as importer name. Example, mobile web. It is recommended that any value be all caps. Okay, recommendation and list value. Pretty straightforward, pretty simple anyway. Pretty simple. It's pretty simple. So, with arguments here, so the exercise is querying products by ID. So querying products by ID, he says specification draft sec ID. Exactly. Which is a scalar. The scalar type representing a unique identifier often used to refer.
Or not, GraphQL isn't only for.
The ID scalar type represents a unique identifier often used to refetch an object or as the key for a catch. Okay, to refetch an object or a key for a catch. The ID type is serialized in the same way as string. However, if it is not intended to be human readable, interesting. It's not intended to be human readable. Well, it is often numeric. It should always serialize as string. Interesting. It should always serialize as string. Okay. GraphQL is agnostic to an ID format and serialized to string to ensure consistency across many format ID. Could represent from small auto-increment numbers to large 120-bit random numbers to base 64 encoded value to string value or format like GUID. GraphQL servers should coerce as appropriate given ID format they expect. When cohesion is not possible, they must raise a field error. Input coercion. When expected as an input type the any string such as 4 or integer such as 4 minus 4, input value should be coerced to ID as an appropriate for the ID format a given GraphQL servers expect. Any other input value, including flow input values such as must raise a request error indicating an incorrect type. Okay. Indicating an incorrect type. Okay. Okay. Indicating an incorrect type. So in any case, let's go to implement this exercise query by product ID. Okay. So much like the in a RESTful way where you define is the specific endpoint for that, and you assign is a proper controller where you in there is going to handle is the logic, and if you want to return a particular, if you want to return data from the controller, your call is the data layer, right? Call model, a proper model.js file from that. But in this case, we define first is the query type, product GraphQL here. We define is the product query type. Let's say product by ID, and we specify is the argument an ID of ID. All right. Question is, wait, what? Delete that. Question is that since product expect is an ID, we should send is an ID for that, right? So there are subtle details that might omitting here. Just like product by ID, and then I need is to create is the proper resolver in the product.resolver here, like this, product by ID, where since this is a arrow function that we're not going to use a parent, in fact we're going to use the argument object as an arrow function. Okay, so we need is to define is on the data layer a function, let's say get product by ID, where you're going to accept is the ID, right? We're gonna pass is the ID, something that we haven't defined right now, and that's where we go to the product model or this data layer and define is that function, that proper function, get product by ID, okay, as an ID. All right. This is a function, and here we're going to, since we're getting is the data, the product data in memory, okay, we're going to filter that data and indicate the predicate to get is only one product, or you can say something like this. You can call is dot find, and get me is the first element that you find based on this predicate, right? which is product product.id, which is equal to the ID, right? And we're going to return this. So return this, okay? We're going to export this function from the data access layer, get product by ID, and then call this product model here, from product model dot get product by ID, assigned to a variable called product, because we're getting it just one single product, and we're going to return that product. So the highlighting here because some syntax error here. So if we refresh this, okay, there's a syntax error here. Where? GraphQL syntax error found. Which line? Yeah, but where? Tutorial language parser. Okay, where do you find that error? GraphQL error. Uh, get product by ID is like not recognizing that. Get product by ID from the product model here. And exporting is this. And that's right. And he throws me this error, but it doesn't tell me where it crashed. GraphQL language. It's the parser syntax error from normal GraphQL error syntax error. Okay. The only thing that I did is I already defined the type here. Of course, the syntax error is on the but it's funny because it doesn't tell you which file. Ooh, it doesn't tell you where exactly. Expected this, not this. Jesus fucking Christ, but it doesn't tell you which fucking file. Oh my god. Okay. You're expecting is a product. Now when we run this uh, GraphQL server, and we querying here is close this as well. And when we fetch this data by price, and we tell, hey, you know what? I want you to get me is by a proper ID. But do we have that product order by an ID? Let's say red shoe. The ID as red shoe. Okay. Interesting. Okay. And get me is only the description. It says product ID, product by ID. It's because perhaps it's product by ID. That's right, it's product by ID, product by ID. Let me refresh here. That's right, ID cannot represent a non-string value, so that's what I assume. Fair enough. Perhaps when they're using is a double quote for that. Exactly. And product by ID, red shoe. Get product.model get product by ID is not a function because we might product.model product by ID get product by ID. It tells me that the get product by ID is not a function. I am exporting that and it's get product by ID. Okay. What about now? We rerun this from this. So we call that again and we get the product by ID. The description is red shoe, right? So cool, by the way, cool. It was a very great experience because I learned from scratch how to do that, and in the meantime, talk out loud what am I doing and what I'm doing, which is essential, especially if you want to explain that to someone else, right? To other developers like that. Mm-hmm. Interesting. So let me
query to get an individual product by its ID. Hopefully by now, you've had a chance to play around and come up with a solution for yourself. Now it's time to check our work. First thing, we'll need to add a top-level query to get a single product based on an argument, which we'll call ID, that matches the type of a product ID. So that's using this built-in.
That actually it was unnecessary lengthy. Yeah, product by ID, or you say product when you define is that as product. You in your resolver say, hey, product. I'm just going to leave like that.
GraphQL ID type, all in uppercase. This is our single argument, which lets us select a single product, so it's definitely required. And the result of our query is a single product. Now, if we have a top-level query defined in our schema, we'll need to have a corresponding top-level resolver, which we can add below products by price. We'll call this just product. And just like with the products by price query, we're not using this first argument, so we'll use the underscore convention to say we don't need that data, but we do need the args. And this is going to contain a value that we'll use to query our product model. In our product model, we'll add a function to get product by its ID. And this function takes in an ID as a parameter and returns one product that matches the passed-in ID. Because our products list is a JavaScript array, what we'll do is we'll return the result of calling the find function on this array, so products.find, which will return the first matching product that matches this predicate or function. So we'll go over all of the individual products in our list, and we'll return true if that product's ID matches exactly the ID in our argument. We can't forget to export this function from our module and call it appropriately from our resolvers. So our product query will return product model.getProductById, and the argument from GraphQL will be in this args.id value. Now, it's worth noting that these IDs that we're passing around are basically just fancy strings that we're calling IDs to make their purpose clear. They're required on every product, but GraphQL won't check to make sure that each ID is unique. We could
I'm going to pause here right now because what I'm doing here is just to use Git, this distributed version control system. So add all of the files that I modified. create a commit by saying, well, parameterize. I think this is the way. How did you write that? Parameterize. 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 Okay. Parameterize. I think I write it correctly. That's right. So parameterize or add parameterize product. Add parameterize to product query. The two product queries. Okay, add parameterize to product query. Then git push to the master or the main. Push to the remote repo to the main branch, right? So when I navigate to this, that's right, and wants to access to that, I won't be able to add. There you got it. That's right. Let me open that here, and voila, right, like this. So if I want to add this, that would be good. And this is something that I'm going to add here. That's right. Here to indicate is the commit folder. That's right. And there you go. Pretty straightforward, pretty simple, but there is a lot of things going on behind the scene. Okay. Okay. Cool. Cool. So close this.
Possibly have two products with the same string ID. In that case, what our resolver here will do in our model is return the first product with that ID. This matches all of the requirements in our schema because the find function will only ever return a single product. So everything should be okay. Let's make sure we've saved all of our changes, and let's run our server, npm start, and test our query in GraphQL. We can now add to our query the result of getting an individual product, passing in some ID. And remember, these IDs are strings. So maybe we want the blue jean product, and we may need to refresh GraphQL to have it detect our new query. And like with any query, we need to be specific about which subfields we're selecting. So inside of these braces, we'll say we're interested in the description and the reviews, specifically including the comment and the rating.
Okay, if you want to get more detailed information about that, that may be also for description and what are you calling here? Reviews. Okay, so review as well with the comment and rating. Comment and rating.
For each review of these blue jeans. All right, let's make our new query. We now have our product coming back, and because no reviews have been added, our reviews field is null. Also notice that our docs contain all of the queries that we've created.
Because yes, I haven't refreshed the GraphQL query here, but that's right.
We can either get all of our products, get product by price, or get individual products by ID. Great stuff.
Let me here add this ID as required for the purpose. And yeah, well,
All right, I'll see you in the next video. Welcome back. Believe it or not, GraphQL isn't only for getting data. Welcome back. Believe it or not, GraphQL isn't only for getting data from the server. We also need to update the existing data in our GraphQL servers. We need to create new data and delete data that's not useful to us anymore. What's the GraphQL way of doing all these things? Let's find out in this video. So far, we've been using GraphQL queries, which fetch data from the server. That's the most basic type of operation that GraphQL servers support. With APIs, getting existing data and reading it is probably the most common thing you'll do. That's why GraphQL focuses on doing queries really, really well. But any real-life backend application needs to support all of our CRUD operations, including creating, updating, and deleting. To do any of these things that change data on the backend, we use what's called mutations. These mutations, along with queries, which we've already seen, are the two main types of operations that GraphQL servers support. So let's get on with it then. How do we make mutations? Right now, none of our products have any reviews associated with them. That's why the value of our reviews field is null. Let's find out how we would let our users add reviews to any product. As you know, when we're getting data from our GraphQL server, we use what's called a query. We've seen that the word query is implied when we don't include the type of the operation. Now, if we're making changes on the server, we make this explicit by always typing the mutation keyword followed by some object. So I'll clear this left-hand panel here, just leaving the mutation part. But we're going to see that mutations are very, very similar to queries. Instead of the names of queries, like orders or products by price, we include the name of the mutation that we're making. To add a new product review, we'll name our mutation add new product review, keeping things simple. Now, just like with queries, we can pass in arguments into our mutation. But unlike queries, the arguments in our mutation contain all the data that we're saving on the server. For reviews, the data we need to capture is a required rating, that's an integer, as well as an optional comment. But also, we need to associate a review with some product, most likely using the product's ID. Those fields correspond to the arguments we pass to our add new product review mutation. Maybe we're adding a review for our red shoe, which had an ID of red shoe. So we would pass that ID as an argument, just like with our queries. ID for the product that we're reviewing is red shoe. What about the contents of our review? We pass that in next. We'll rate these red shoes a 5 out of 5, and our comment will be that they're really great for coding. All right. Now, our mutations, just like our queries, can return some data corresponding to the mutation that we made. For example, maybe the server is generating a unique ID for our review that we don't already have access to on the front end. We could get that just like we do with queries, adding these curly braces and putting in the names of the fields we're interested in from the response. What we're essentially doing here is making a change on the server and getting the newly updated data back all in one mutation. This is especially useful if we're updating part of an object that already exists and we want to get the final state of that object after our changes. We'll keep things simple and just return back the rating and comment for the review that was just created. To be absolutely sure that everything is working, we can get back the rating we just put in. And there we have it. Our first mutation, nearly identical to a query, with the exception that we use this mutation keyword, and our mutation is changing some data in our server. Let's keep things short and implement this mutation in the next video. We'll see that mutations are very similar to queries under the hood. The key thing is that we use the mutation keyword to let us know that we're about to make some changes and not just fetch some data. The word mutation comes from mutate, which just means to change. All right, let's make some changes to our GraphQL backend. I'll see you.
Okay. With this, I'm going to wrap up this video and wish you the best. Take care. Bye-bye.